There are several reasons why using a 120/277 volts rated switch at 24 volts may not be ideal. Firstly, the switch's current handling capacity is a critical factor. A 120/277 volts switch is engineered to manage a specific range of current at those higher voltages. When employed at a low voltage, like 24 volts, it might not effectively handle the same current levels. This mismatch can potentially lead to the switch overheating, which could ultimately result in its failure. Secondly, the sensitivity of the switch plays a significant role. A 120/277 volts switch is designed with a certain sensitivity to detect even minimal amounts of current flow. However, at a lower voltage, the switch's sensitivity might be compromised. This reduced sensitivity could make it more challenging to reliably turn the switch on and off, impacting its intended functionality. Thirdly, the durability of the switch is another important consideration. A 120/277 volts switch is built to endure a specific level of wear and tear, reflecting its intended use in higher voltage applications. When subjected to a low voltage environment, the switch's expected lifespan might be negatively affected. The reduced voltage could diminish its ability to withstand the physical stresses and operational demands, potentially leading to premature failure. As a general guideline, opting for a switch that is appropriately rated for the specific voltage being used is highly recommended. Selecting the correct voltage rating ensures that the switch can effectively manage the current demands, maintain the necessary sensitivity for reliable operation, and provide the expected durability for long-term performance. In scenarios such as a 3-position momentary contact switch intended for a lighting control system, selecting a 24-volt switch is typically the most suitable choice. This is because a 24-volt switch is specifically designed to handle the low current levels that are commonly found in lighting control systems. Furthermore, it possesses the required sensitivity to accurately detect even small current variations, which simplifies the process of turning the switch on and off. A 24-volt switch is also built to withstand the wear and tear associated with lighting control system operations, contributing to its longevity and dependability. To elaborate on the technical aspects, let's consider the implications of using a switch rated for a much higher voltage in a low voltage circuit. Switches are designed with specific contact materials and internal configurations optimized for the voltage and current they are intended to handle. When a high voltage switch is used in a low voltage application, the contact resistance might be higher than optimal for the low voltage circuit. This increased resistance can lead to several problems. Firstly, it can cause a voltage drop across the switch, reducing the voltage available to the load. In a lighting control system, this could mean that the lights do not receive the intended voltage, leading to dimming or inconsistent performance. Secondly, the increased resistance can generate heat. While the heat generated might not be enough to cause immediate failure, over time it can degrade the switch's components, reducing its lifespan and potentially leading to intermittent failures. Thirdly, the switching characteristics of the high voltage switch might not be suitable for the low voltage circuit. High voltage switches are often designed to handle the inductive kickback that occurs when switching inductive loads such as motors or transformers. In a low voltage lighting control system, the loads are typically resistive, and the switch might not be optimized for this type of load. This can lead to contact bounce or other undesirable switching behavior. Moreover, the materials used in high voltage switches are often chosen for their ability to withstand high voltage arcs. When a switch opens or closes, an arc can form between the contacts. High voltage switches have features, such as arc sheets with special contact materials to extinguish this arc quickly and safely. In a low voltage circuit, the arc is much smaller, and the switch's arc quenching features might not be effective. This can lead to contact erosion and reduce switch lifespan. In addition to these technical considerations, there are also regulatory and safety implications. Electrical codes, such as the National Electrical Code, often specify the type of switch that must be used in a particular application. Using a switch that is not rated for the voltage and current of the circuit can violate these codes and create a safety hazard. For example, if a high voltage switch fails in a low voltage circuit and causes a fire, the insurance company might deny coverage because the switch was not properly rated for the application. Furthermore, using a switch that is not properly rated can create a risk of electric shock. If the switch's insulation breaks down, it can expose conductive parts, creating a shock hazard. This is especially dangerous in damp or wet environments. When designing a lighting control system, it is essential to consider the voltage and current requirements of the system and to select switches that are properly rated for those requirements. Using the wrong type of switch can lead to performance problems, safety hazards, and code violations. To further clarify the differences between 24 volts and 120/277 volt switches, let's delve into their construction and operational characteristics. A 24-volt switch is typically designed with smaller contacts and a lighter duty mechanism compared to a 120/277 volt switch. This is because it is intended to handle lower currents and voltages. The contact material might also be different, optimized for low voltage operation. A 120/277 volt switch, on the other hand, is built with larger contacts, a more robust mechanism, and higher quality insulation. This is necessary to handle the higher voltages and currents and to withstand the potential for arcing. The switch might also include features such as arc chutes or barriers to prevent arcing from spreading. The operating principles of the two types of switches are also different. A 24-volt switch typically uses a simple on/off mechanism with minimal contact bands. A 120/277 volt switch might use a more sophisticated mechanism to ensure clean and reliable switching, even under high load conditions. For example, it might use a snap-action mechanism to quickly break the circuit and prevent arcing. In addition to these physical and operational differences, there are also differences in the way the switches are tested and certified. 24-volt switches are typically tested to lower standards than 120/277 volt switches. This is because they are used in less demanding applications. 120/277 volt switches, on the other hand, are tested to rigorous standards to ensure that they can withstand the stresses of high voltage and current. These standards often include tests for voltage withstand, insulation resistance, and short-circuit protection. When selecting a switch for a lighting control system, it is important to consider not only the voltage and current requirements but also the environmental conditions. If the switch will be exposed to moisture, dust, or extreme temperatures, it is important to choose a switch that is rated for those conditions. Some switches that are designed with sealed enclosures to protect them from the environment. Others are made from materials that are resistant to corrosion or degradation. It is also important to consider the type of load that the switch will be controlling. Some loads, such as incandescent lamps, draw a large inrush current when they are first turned on. This inrush current can damage the switch contacts. If the switch will be controlling an incandescent load, it is important to choose a switch that is rated for the inrush current. Other loads, such as electronic ballast, can generate harmonic currents that can damage the switch. If the switch will be controlling an electronic ballast, it is important to choose a switch that is rated for harmonic current. In summary, using a 120/277 volts rated switch at 24 volts is generally not recommended due to potential issues with current handling, sensitivity, durability, and regulatory compliance. It is always best to use a switch that is specifically designed and rated for the voltage and current of the circuit in which it will be used. This will ensure optimal performance, safety, and longevity. Selecting the correct switch involves considering the voltage, current, environmental conditions, and type of load. By carefully considering these factors, you can choose a switch that will provide reliable and safe operation for your lighting control system. Remember to consult relevant electrical codes and standards for specific requirements and recommendations. Furthermore, consider the long-term maintenance and replacement aspects. Selecting a commonly available and easily replaceable switch can minimize downtime and reduce maintenance costs over the lifespan of the lighting control system. Documenting the switch specifications and part numbers can also simplify future replacements. In addition, proper installation is crucial for the safe and reliable operation of any switch. Follow the manufacturer's instructions carefully and ensure that all connections are tight and secure. Use appropriate wiring methods and materials, and protect the switch from physical damage. Regular inspection and maintenance can help to identify potential problems before they lead to failure. Check the switch for signs of wear or damage and replace it if necessary. Keep the switch clean and free from dust and debris. By following these best practices, you can ensure that your lighting control system operates safely and reliably for many years. In conclusion, while 120/277 volt switch might seem like it could theoretically function in a 24-volt circuit, there are significant reasons to avoid this practice. These reasons include potential problems with current handling, reduced sensitivity, decreased durability, and potential code violations. Always choose a switch that is specifically rated for the voltage and current of the circuit to ensure optimal performance, safety, and longevity. For a 24 volts lighting control system, a 24 volts rated switch is the appropriate choice. Remember to consider the environmental conditions, type of load, and maintenance requirements when selecting a switch. Proper installation and regular maintenance are also essential for safe and reliable operation. By following these guidelines, you can ensure that your lighting control system operates efficiently and safely for its intended lifespan. Selecting the correct components for any electrical system is paramount, and lighting control systems are no exception. The seemingly minor decision of choosing the right switch can have a significant impact on the overall performance, safety, and reliability of the system. Therefore, taking the time to carefully consider the factors discussed above is a worthwhile investment. The differences in switch design and construction are not merely arbitrary. They are the result of engineering principles aimed at optimizing performance for specific voltage and current ranges. Using a switch outside of its intended range can compromise these design parameters and lead to undesirable outcomes. The choice of materials, contact size, spring tension, and insulation levels are all carefully calibrated to ensure reliable operation within the specified voltage and current ratings. Deviating from these ratings can disrupt the delicate balance of these factors and introduce potential failure modes. Furthermore, the regulatory landscape surrounding electrical components is designed to protect users from hazards. Electrical codes and standards are based on years of experience and research, and they represent a consensus on best practices for ensuring safety. Violating these codes by using improperly rated components can create a significant risk of fire, electric shock, or other hazards. Insurance companies may also deny coverage in the event of a claim if it is determined that the electrical system was not installed in accordance with applicable codes. Therefore, adhering to these codes is not only a matter of compliance but also a matter of responsible and ethical practice. In addition to the technical and regulatory considerations, there is also the practical aspect of long-term performance. A switch that is not properly rated for the application is likely to fail sooner than a switch that is. This can lead to increased maintenance costs, downtime, and inconvenience. Replacing a switch can be a time-consuming and disruptive process, especially in a complex lighting control system. By choosing the right switch from the outset, you can minimize the risk of future problems and ensure that the system operates reliably for many years to come. In conclusion, the decision of whether or not to use a 120/277 volts rated switch at 24 volts is not a matter of simple substitution. It is a decision that requires careful consideration of technical factors, regulatory requirements, and practical implications. By understanding the differences between switches designed for different voltage and current ranges, and by adhering to applicable codes and standards, you can make an informed decision that will ensure the safe, reliable, and efficient operation of your lighting control system.